actually dabble or venture into the calculations, we have to actually try to make sure you understand these basics. These basics are what will help you to be able to solve complex calculations. So the other time we talked about the fundamental quantities and the derived quantities, and we were able to prove some derived quantities owing to their unit with respect to the fundamental quantities. So today now we are going to dimensions. Yeah, dimensions. Yes, dimension. So our topic for today now is dimension. So dimension is actually a special aspect of physics that has to do with the physical, that the physical quantities or the physical nature of those quantities. So it's a special aspect of physics that has to do with physical natures. So whatever we are going to discuss under the dimensional quantities, or if this is your first time of actually watching our videos, please click on the subscription button and like, let your comment, and let us enjoy the ride. We have a lot to do, as I told you. Now, we want to talk about the dimension, and let's assume quantities. Quantities. Then we have the formulas. Formulas. Then dimensions. So, and note that these dimensions have to do with the fundamental quantities, the real symbols of the fundamental quantities. We have the mass, which is represented by the M. Then we have the time, which is represented by the T. Then we have the length, which is represented by what? The L. So this physical nature or the physical symbol of these quantities are what we are going to use to estimate or evaluate or derive our dimensions. So now we have the dimensions as a quantity. We have the formulas, then we have the what? We have the dimensions. First of all, let's talk about area. Area, which is the quantity. What is the formula? Length times length. You know, we have length times breadth. So the dimension with respect to this now is going to what? L squared. Then volume is what? Length times length times length, because we are relating it with what? With the physical quantity. Length times breadth times height. So length, L cubed. This is dimension. Then velocity, which is what? Which is distance over time. Distance over time. So it's denoted now at this point as L over T, not unit. So it's going to be what? L T minus 1. In indices, the inverse carries minus 1. Then we have acceleration. Acceleration, which is equal to what? Velocity over what? Time. So what's the unit of velocity? The dimension of velocity is what? Is Lt minus 1 over what? Over time. So the dimension is what? Lt minus 1 times T minus 1. So it's going to be Lt minus 1 minus 1 minus 1. So it's going to be what? Minus 1 times minus 1, it will be also minus 2. From indices, at the end we are going to have Lt minus 2. That's the dimension of acceleration. Now we're going to force. Dimension of force. Please, so that we can have a lot to do. So dimension of force is what? Force is actually distance, mass times acceleration. So what's the dimension of mass? Mass times acceleration. And what's the dimension of acceleration? Acceleration is this, Lt minus 2. Or we can say, okay, let me write it in full. Mass times acceleration, yes, which is M times Lt minus 2. So at the end it's going to be, what dimension is going to be MLT minus 2. This one minus 2. So that's the dimension of force. Now let's talk about momentum. Momentum now. Momentum. Yes. Momentum now is a product of the mass times velocity. Momentum is a product of the mass times velocity of a substance. So mass times velocity, so which is what? M. Then what's the dimension of velocity is what? Lt minus 1 times Lt minus 1. So the dimension for momentum now is going to be M Lt minus 1. Yeah. So what about pressure? Pressure is what? Pressure is force over area. Force over area. So what is the dimension of force? Dimension of force is MLT minus 2. MLT minus 2. What is the dimension of area? It was L squared. L squared. So by the time we do the simplification, at the end of the day, it's going to be M dot L, which is the L at the top, then the one at the bottom is going to be minus 2, then dot the T minus 2. So at the end of it, it's going to be M minus 2 plus y to give us what? Minus 1. L minus 1, T minus 2. So that is the dimension of pressure. Then the last one we're going to talk about now is the dimension of power. Yes. Power, you know, I told you power is what? Is work over time. Work over time, which is force times distance over what? Over time. So that you don't make a mistake. So that is the dimension of power, and that is how we are going to be getting this dimension as far as much as the formulas. And then I would like you to the units now of this now unit of area, which is L square, which is going to be what? Meter square, is going to be meter square. So this one now meter, it will be meter cube. Then this one now, the length is what? Is what? Meter. So we can say meter time is what? Seconds. This one minus 1 meter per seconds. Now that of the acceleration is what? Meter. Then time is seconds, meter per second square. Do you see now? Then that of the force now, which is meter, then sorry, the M is kilogram. So kilogram meter per second square. So we can also say this is unit for force. Then for that of the momentum now, M is what? Kilogram, then L is meter, then T is per seconds. Then for that of the pressure now, let's say kilogram, then meter per meter, then per second square. Then that of the power now, you can say kilogram, then meter cube, meter square, yes, per second square 4. So let us, so like this kilogram per meters per kilogram meter per second square can also be written as what? Newton. That's the unit of force, mass times acceleration, Newton. Then this momentum, which is mass times velocity, yeah, this kilogram meter per second. This is it, that does it. Then this pressure, which is force, yeah, that's it. Then that of the power, yes. Now, if you can remember vividly, another unit for power is, we can say power is joules per second, isn't it? So, but there is no how we can actually evaluate this, but let's leave it the way it is now as kilogram meter square per seconds raised per what? Minus 4. Hey, sorry, a mistake was done earlier on. Sorry, this is actually T raised per minus 2, which is the time. I made a mistake by putting minus 2, yes, okay, minus 2. So it is minus 2 now. Having this T minus 2 times minus 1 to give us minus 3. So it's not minus 4, it's minus 3. So also let's correct this. So this minus 3. So and then yeah, others are correct. So these are good. So when we evaluate this, remember the length times the length will give us length squared. Then T minus 2 times T minus 1 to give us T minus 3. So raised by 3. So that's it. So that's the dimension and the unit of power, this is the unit, this is the dimension. So it's as easy as that. So subsequently now we are going to be solving calculations on physics that will help us, that will enable us to use this formula. Please stay tuned so that you can be updated. Subscribe please so that we can actually let you know when we shoot our video. Place your comments there, like. Thank you very much. Love you.